Okay, so we had the introduction to quantitative methods as a qualification we developed. We were working on the Critical Maths project with DFE funding. So when it came to developing core maths qualifications, in a way, the natural thing was to put the two things together, and there we go. But we actually did quite a bit more thinking than that. We didn't just think, oh, well, here's two we've got sort of nearly ready, let's just put it all together. It was a thought process that I'm going to take you through, because I think it was interesting to us, and hopefully it will be to you. So that's a sort of recap of what the two qualifications that we wrote for the core maths market look like. The introduction to quantitative methods is a level 3 certificate. It was written for first teaching in September 2014, and I sort of almost thought it was 2013 because it feels like a long time ago, but people were just starting to teach it 3 months ago for the first time. And that arose from our work on the Integrated Mathematical Problem Solving project. You can put it together with S1 and D1 from the MEI A level to make an AS in quantitative methods. That's got a limited lifespan because the modular A levels and ASs are coming to an end. So clearly we're going to have to do something about it at some point in time. The things we put into the introduction to quantitative methods were based on our findings from that project, looking at the maths that was needed in other level 3 courses, but also looking at the maths needed for employment. So there's the use of spreadsheets, modelling and estimation, statistical problem solving, but mainly using GCSE techniques, but using them for a purpose, financial problem solving, including percentages and foreign exchange. When I actually wrote it, I didn't write a separate section on percentages because I thought, well, actually, I want people to realise that percentages in real life are often to do with finance, and behold, the pound is conveniently divided into 100 pence, so it actually gives them something to sort of hang their understanding on. And then other applications of percentages can be an extension of that. It deals with exponential growth as a model they might come across. It deals with standard form, because I think that if they're using a spreadsheet, they'll see things in standard form sometimes, but perhaps not in the way they've seen them before. If they've done standard form before, and if they've done foundation tier at the minute, they might never even have done it. And it deals with logarithmic scales on graphs and being able to understand how they work, but not logarithms as such. Gradient as a rate of change on a graph, because I think it's important that students are able to look at a graph and understand what it means when it's getting steeper or less steep, and probability and risk. There are 3 cycles that students are introduced to or use in that course to help them with their thinking about various different kinds of problems. So there's a modelling cycle. And the easiest way, I think, to understand it and for students to understand it is to actually think about a problem that you might want to use this cycle on. Now, at some point in time, when the postman comes, you will get a set of postcards that include some problems that might arise in a core maths type course, or that you might want to use with your students perhaps. And one of the problems is one that is dear to my heart. I have a pedometer, it is in my handbag today. If I had a pocket, it would be in my pocket. I bought it to try and stop myself getting grossly unfit, and my pedometer is happy with me when I do 10,000 steps in a day. So the question naturally arises, how much of my day does all that walking about take up? Now, clearly, I could do it experimentally and get up in the morning and keep walking until my pedometer starts cheering me because I've got to 10,000 steps, and then look at the clock. But perhaps it's interesting to think about how long that's likely to take. Now, in order to do that, I need to make some assumptions, perhaps about how fast I can walk, perhaps about how much I'm able to sustain that over time, and I can come up eventually with an estimate of how long I think it might take me to walk 10,000 steps, and then I can actually perhaps walk to the end of the street or do whatever I'm doing, see how far I've walked, and just have a check that the time it's taking me in reality is similar to what I've come up with by calculation. The financial problem solving cycle is one that we came up with when we were looking at the financial stuff for the all-party parliamentary group. There was a big debate then as to whether financial thinking belongs in maths or whether it belongs in PSHE. And different people had different views. Some people were very firmly of the opinion that, well, maths, it's just about calculations. And financial understanding is about people's personal lives. And unless you bring those kinds of thinkings in, they'll never be able to understand finance properly for themselves. So you'll notice in the sort of bottom left-hand corner, there's a box that says take account of personal and ethical considerations, because we came to the conclusion that actually, as well as the calculations, there are sometimes personal views that people might have or personal circumstances they might have that makes a difference to what they decide. So if we think about the situation of finding somewhere to live on whatever wage you've got coming in, well, clearly the question is, where can I afford to live on this money? And you need to find out how much places cost. You need to also think about what else the money's going to go on. Having done all that, you might then come up with a range of places that you could afford to live. That's where the personal considerations might come in. You might prefer some places to others. There might be some areas you don't want to live in because they're not very nice areas. There might be some areas you do want to live in because it's near to public transport opportunities, or it's near to your friends, or it's near to something else. All those kinds of things come into that final decision, and that's why that sort of personal and ethical considerations box is there. Not sure that ethical considerations with finding somewhere to live, it may be to do with whether people want to take out a mortgage or a loan or something else. There's a statistical cycle, which is perhaps a bit more familiar from GCSE. That's a sort of 4-stage cycle that might then repeat if you need it to. Sorts of questions that might arise there are perhaps things like in a business context, people might be thinking about, well, people that shop in our town centre, where do they come from? How do they get there? Do they drive so that they need a parking space? Do they come by public transport? Do they walk? What does that mean for our local economy? How do we find that out? Well, clearly you ask people, but you can't ask everybody. So who do you ask? How do you organise that to make sure that the information you're getting represents the true situation? How do you then deal with that information? Is the answer that you've got a reasonable answer? All those kinds of things are coming into it. The introduction to quantitative methods, which is our old qualification that's been around for a whole year, has a 1.5-hour exam and a piece of coursework. We put the coursework in because it allows people to go through that statistical cycle for real and to use a spreadsheet to analyse the results, both of which are quite difficult to do in an exam. You can't really ask people to do the whole of a statistical problem-solving cycle in an exam. You can ask them to do bits or to reflect on things they've done. You can't ask them to use a spreadsheet in an exam terribly easily because of access to equipment. You can ask them to understand printout from spreadsheets, which we do in the exams, but to actually use one, we can't really assess that unless we have coursework. Now, we didn't just include it in the new development of these 2 qualifications because it was there and we'd already done it and it saved us some work. People were starting to teach it already. And they were quite enthusiastic about it. It wasn't anything to do with sort of national initiatives for core maths or whatever. It was designed particularly with students and teachers of subjects like biology, perhaps, or psychology in mind. And schools genuinely thought this is going to help our students. It's going to help them understand better the kinds of skills they need for the subjects that they're really interested in. Maybe they're not interested in maths for itself, but they still need some of those skills. They'll need them within their A-levels to a certain extent, and they'll need them more if they go on to university. That's going to become an increasing consideration from 2015 onwards, where some of the new A-levels, particularly in subjects like business and chemistry and computer science, have got a specified percentage of questions that have to be on quantitative skills. So ideally, if students are doing this sort of qualification, it will help them in the subjects they're really interested in, if they're doing A-level. When we did the new development, we talked to teachers about what sorts of things should be in there. We talked to other people. we decided not to include coursework. I had to think long and hard about that. I liked the coursework. As I say, it helped to assess certain skills that you really cannot get at in an exam. But the teachers we talked to were fairly strongly of the view that they really didn't want to do it. And I thought, well, maybe 5 years down the line, when people have done it and feel as though it's valuable and useful and it isn't as awful as other experiences they've had with coursework, maybe things would be different. But at that stage, nobody had taught it. Nobody had actually done the coursework for real. And I thought, what am I going to do? Am I going to tie myself to some railings and fight for the coursework, or shall we listen to the teachers and do what they feel? And in the end, I thought, well, actually, some people's experiences with coursework have been awful for all sorts of reasons that I won't go into now. And if that puts them off from doing these qualifications, it isn't worth it for the small percentage of the marks that it's available for. So I decided to go with what people felt and think, OK, I'm going to listen to the teachers and we won't have coursework and we'll do our best without it. We still want all those skills taught and happening in classrooms, but we won't actually include it in the assessment. We talked to higher education and employers, and there was some content we hadn't included. Things like maps, diagrams, scale drawings, that they said, oh yes, this is useful for people doing all different kinds of jobs. Lengths, areas, volumes of similar figures comes up in subjects like biology. Ratio and proportionality is very important all over the place, so we included some extra content that we thought would be useful. And for both of those things, the introduction to quantitative methods that we'd already developed and the introduction to quantitative reasoning that we were recycling from the introduction to quantitative methods before anybody had ever taught it, our thinking was, what's the maths that is going to be useful to students, and then what sorts of things can they do with it? So here's a question from the Specimen papers. Now, I don't know sort of whether you think about when you change your foreign currency to go abroad, or when you're abroad and you're changing money, how that information is displayed. It was drawn to my attention when my cousin came over from Poland and he'd got all these zlotys to change into pounds, and of course he wanted to get the best deal for his money, so I took him round all the places in Skipton that did money changing, and the information was just like that. And I had to think, now, which number do I want? Do I want the sell-out number, or do I want the buy-out number? And is a big number better than a small number? And I had to do quite a lot of thinking there. And I thought, well, those are the sort of skills that actually are useful for students, not just because they can get the best rate on their foreign currency exchange, but because the kind of thinking they're doing is the sort of thinking that comes up in other areas. And if they can do this sort of thinking, then they're going to be able to do lots of things that are useful in other subjects and useful in employment. Our thinking in critical maths was a little bit different. It was, what kind of questions do students need to be able to think about and solve? And then what's the maths they need? So it was sort of the opposite way around. And that doesn't necessarily come naturally to me as somebody who's been doing maths all their life, but it is the way around that other people think. And when I've sort of gone to talk to other people, I've talked to sort of people involved in financial education, and they were saying, at last you mathematicians see the point. Instead of trying to think about what you can do with all this maths you've taught them, you're starting to think about what do they actually need to be able to do, and so what are the skills they need, what is the techniques that they need to be taught. Once we'd started thinking about critical maths and got the hang of what sort of problems it involved, I started seeing it everywhere, and it isn't just because I'm obsessed. I think it actually is everywhere. So I'm going to give you some examples. That's from last year's QI Factbook. I think they perhaps bring out one every year round about Christmas, because I see they're advertising another one this year. This one was reported quite widely on the internet and in various magazines. North Americans are less than a 16th of the world's people, but more than a third of their weight. And that's from 1339 QI Facts to make your jaw drop. Well, after it had made my jaw drop, I started thinking, well, could that actually be true? So I shall give you a few moments in a problem-solving kind of way to let you think about that. I promise not to pick on anybody to ask them what they think. Now, isn't that interesting? You've all, or a lot of you, have started talking to each other. Nobody's said to me, what are we doing this for? When am I ever going to need to be able to use this in real life? Which is a phrase I did sometimes used to hear in my GCSE classes. Now, some people perhaps wouldn't find that an interesting question. It so happens I saw it and I did find it an interesting question, so I did some thinking about it. I ended up writing an article for Significance magazine, which is a Royal Statistical Society magazine. You can find the article online, should you be interested. Well, even if you're not interested, you can still find it online, but I'm not going to force you to read it. Eventually, once I'd thought about it a bit, this was the way I found to represent the situation to help me make that decision as to whether it could be true that a 16th of the world's people are North Americans, but they're more than a third of the world's weight. Now, it might be that looking at that diagram, you can see exactly how that helps you to think about it. Or it might be that you can't. It's okay, it took me about 3 days to get to that diagram. I thought of it in all sorts of other ways first. I did it with numbers, I did it sort of thinking about it, and I thought, yes, I can do this diagram. And I think actually that's a helpful thing for students to realise, is that sometimes a really nice way to solve a problem isn't the first way they think of. And of course, in an exam, they haven't got time to solve question number 1 in a really, really nice way and then forget everything else. They'll just have to do it as best they can in the time. But in lessons, you've got time to compare people's solutions and say, well, does this help us? Is that a nicer way to think about it? Does this allow us to see what's going on better than that way of thinking about it? And hopefully they'll develop some strategies that they can use in all different places. We've been talking about reforming maths A-levels for I don't know how long. Now, sometimes I go to meetings about such things, and I found myself in a meeting with some university lecturers who are wise people who know a lot of stuff, and they told me that A-level further maths is much too easy and we want to sort it out. And I said, what makes you think that then? And of course, they said to me, well, it's obvious because 25% of further maths students at A-level get an A star, and for biology, it's only 10%. So clearly, further maths A-level must be easier than biology, and you want to make it harder. Make it as hard as biology. Now, is that reasoning correct, or is there something else going on? Now, I was mildly irritated by this experience, although I try not to show it. And so I went away and thought, I wonder what happens at degree level. And I discovered that clearly maths degrees are much easier than biology degrees because 30% of students who have a maths degree have got first, and for biology it's only 15%. Now, I'm not here trying to sort of get at biology or pick on it or anything. That just happened to be the example that the lecturers used, so it was the one I looked up. I mean, I think it is the case that for maths degrees it's one of the highest proportions of firsts. So there you go, you can tell all your students what an easy subject maths is and how is it that they're not better at it than they are. What else is going on there? On holiday, I couldn't get away from this. I was on my Ryanair flight reading my Ryanair magazine, which proudly told me that Ryanair mishandles fewer bags than any other airline. And this is a standard way of comparing across the airline industry. Only 0.38 bags per 1,000 passengers go astray for Ryanair. The European average is 9.4. Well, is that not impressive? The thing that I'm aware of, having booked with Ryanair, and if you haven't, I honestly feel as though there's a part of life that perhaps you've sort of, you've missed out, and it's an experience booking a ticket with Ryanair. It cost my bag £60 to go on holiday and back, which is roughly the amount it cost me, but I got a seat inside the plane and my bag didn't. Because it costs as much for your suitcase as it does for you, a lot of customers just go with cabin baggage, and there's a lot of, sort of making sure it's optimally packed and you've got the biggest bag you can and that your pockets are full of stuff as well. So actually, there's a lot fewer of Ryanair's customers than for the average airline that actually have a bag that could be lost. So perhaps that's not the best way of comparing, and perhaps maybe a different way of comparing would be fairer. I'm not saying that Ryanair aren't more careful with people's bags, they maybe are, but I'm just saying that maybe bags per 1,000 passengers is not the most fair way of comparing. So once we'd started thinking about all these different kinds of questions that we wanted students to be able to do, rather than focusing on what maths we want them to learn, we then had to put it in a qualification. And that then raised the question of how do we organise it? It's not sort of algebra, number and geometry anymore. How do we organise it? And I am indebted to Roger, who came up with a very large and possibly complicated looking at first structure for organising our thinking. Now, I'm not suggesting that you teach this to your students as a way of organising their thinking, but it may be helpful for you if you're trying to push students on in their thinking to sort of think, well, whereabouts are they in this process? So it starts with a problem to solve, or maybe a statement to evaluate that involves some kind of quantitative information, or perhaps some sort of general question where there's some maths in there, but maybe it's slightly less obvious. And that's the sort of top box in that diagram that you cannot see because it's too big to put on a slide. The next bit that's sort of shaded in on the diagram is two columns, one that looks at the mathematical processes that students are going to and one that looks at the skills that they're using in doing those processes. So, I mean, if you're working with students and they've sort of got stuck somewhere, have they thought of any strategies that they might use? When I was looking at that North Americans question and could they really be a third of the world's weight, I thought, well, how can I investigate this? And one of my first thoughts was I'll think of some numbers and see if how that works. And that's often a good strategy. Then I tried drawing a diagram and that proved to be a better strategy. So it can be a help to you to sort of push students on. It was a big help to us in actually organising the content, because this is what a page from the specification looks like. The heading isn't sort of any particular area of maths, it's just mathematical and statistical techniques and knowledge, because that's what this particular page is about. This one's about fallacies and statistics and probability that we'd like students to have some familiarity with during the course. Now, here's an exam question from the Specimen assessments. People have asked me about this one. And it's some data from the 2012 Olympics. Usain Bolt, his times for the 100 metres and the 200 metres. And it kind of raises the question, is which race was he fastest in? And it isn't obvious, because if you're a dedicated follower of sport, or even if you're like me, you're not a dedicated follower of sport, but you kind of think it's interesting to watch Usain Bolt racing, you'll be aware that he's not very good at starting. That's the bit he's slowest at. So maybe in the 200 metres, which gives him longer to do the running, maybe he's quicker in that. Or maybe he's quicker in the 100 metres, because although he's got the start, he hasn't got to go as far. It's not an obvious answer, just knowing something about how he runs. Of course, you can use a calculator and work out his speed in metres per second for each race. But in this particular case, that is not the best strategy. And that's why I've said in the question, don't use a calculator, because I would like students to adopt a better strategy where they have to do some thinking, as opposed to, yes, I know, speed is distance over time, I'll put the numbers in and come out with these awful decimals that I've then got to try and compare. And then we sort of came back to thinking, have we actually catered for the vocational students here? Because we've talked, or at least I have, you haven't, you've been sat there listening to me, about what students need for their other subjects at A-level, which is a big part of our thinking, partly because that's the experience that I have of teaching. So I understand that, and there's these changes going on at A-level to increase the quantitative content. Now, what about the people that are going on to employment? There was a report came out in 2013, which is an interesting report, and one of the findings was that the level of maths that students need in the workplace is by and large the stuff they've learnt at GCSE, but the sort of questions that they need to be able to address with that maths is by and large not the sort of questions they've done at GCSE, and they put it as simple maths in complex settings, and that kind of echoed with what we were doing in the critical maths project, because that's the sort of phrase that's come up a lot in our advisory group meetings, that what we're doing is using simple maths to look at complex problems. Often it is just things like ratio or proportion or understanding averages or percentages, but they have to really be able to use it in a wide range of settings. And if they can do that, it almost doesn't matter what sorts of questions they've thought about, but they will be really well prepared for work.